Hi, welcome to Mathematics with Tom. I am Tom, and this is the first video in my Linear Algebra series. This series is based on the text of Introduction to Linear Algebra by Gilbert Strang, and we'll be going through the book. And we're going to start in section 1.1. And that all begins with learning what is a vector, and that's what we're going to do today. So come with me, we're going to come over here, and let's start out with what is a vector. Vectors. Here we go. A vector is an ordered pair indicating both direction and length. Direction and length. And for length, you might also hear sometimes, you might hear it referred to as magnitude. Okay. And I'm going to say it this way. Let's see. A vector is written in boldface, block. Since this is just chalk, I can't do bold, but I can do is written in block type. Is written in block, and its components in script. Okay, so I'll show you exactly what I mean by this. So we write the vector x, so that'd be my block face for block, in R2. This may be a new notation to you. If it is, this R2 is what we would represent just as simple xy when we make a graph on a Cartesian plane, the xy grid. That's what R2 is, and so this is our notation for that. So we write the vector x in R2 as, so we write block face, or block x equals, and we have a script x1, x2. Now, so that way we know that the vector x, we're going to use components in x. If this was the vector v, we would use script v's and so on. But to help you understand this, remember this is just an ordered pair. And the most simple ordered pair you've seen was when you started plotting points and graphing lines. And we plotted the ordered pair x, y. So this would be similar to just saying x1 would be the x value, x2 would be the y value. Okay. Also x in R2 had always has exactly two components. use two more examples. the vector y in R3 has 3 components. Has 3 components. So we would write it as y would have, it would have a y1 component, it would have a y2 component, and it would also have a y3 component. And then we always write it in this vertical, this column form, and we use brackets. Sometimes you may see it done with large parentheses, but to be consistent with our author, we're always going to write it in this notation. Also, if you've taken a calculus class and encountered vectors there, or in some other classes, sometimes you'd see the vector y written this way. It'd be y with an arrow over it, like that. That's also a vector. Either notation is fine. It's usually contextual, and again, since we're going to be studying vectors this whole semester, it makes sense in this context that we don't really need to bother by writing an arrow. So we won't do that. We'll always use a nice block style letter and script style letters. But for clarity, and maybe if your handwriting isn't so well, then make sure you use the arrow if it helps. Okay? Finally, well, let's do one more, is in general this. In general, a vector in n-dimensional space. N-dimensional space, we'd write it as Rn has n components. It has n components. So let's come over here. It has n components. So I should have said a vector, or let's put it here, a vector v. There, that looks better. A vector v in Rn. So v would look like this. V equals, it would have a v1 component, it would have a v2 component, it would obviously have to have a v3, but you could go to v4, v5, v6, as many as you needed to some final number. And that would be your n-dimensional vector. And those 3 dots, the ellipsis, that just represents I didn't want to, if this was 10, I just didn't write v4 all the way down to v9. So the pattern would continue. So let's take a look. Example. We'll call this examples, a quick sketch. Quick sketch. So what do we mean? Let's take a look at x. So we said that x has 2 components. It was x1 and x2. If I was to draw the vector x, well, let's just take a look at our Cartesian plane. Remember, we have an x-axis and we have a y-axis. And I could put my x1 anywhere. Let's say maybe x1 was here. And maybe x2 is here. Then my vectors are very commonly drawn in purple. No, any color mat is fine. But my vector x then is the arrow from the origin to the ordered pair x1, x2. Okay? Let's take a look. Some of you may have drawn a 3D graph, and if you haven't, that's okay. We're going to be doing that in one of the upcoming lectures. So, but a quick sketch is if I looked at y, well, we said that y, it was in 3 dimensions. So it had 1, 2, and 3 components. Well, 3 components. So what has to happen is, that means there's an x component, there's a y component, and then there also has to be a z component. And you could think of it as, this is just a flat board. Well, what you would also need is you need to add dimension to it. So you could think of it as something coming directly out of the board and going directly into the board. So here's how we sketch this. We take our x and y and we draw them at this angle. There's my x-axis, here's my y-axis, and then the part that's, we said the part that would be coming out of the board or going into the board is the z-axis, and that we represent by going up. And so if I was to sketch this, I might sketch something like this. Here's x, oops, y. Here's my y1, goes on the x-axis. My y2 value goes on the y-axis. And finally, my y3 value goes on the z-axis. And so we're going to learn how you draw these. But essentially, you don't need all those little dots. You have a vector that comes up into space like this. That would be how you would draw the vector y. And that is how we draw, that is the basic idea of all a vector is. It's an ordered pair indicating direction. So this arrow is heading in this direction, and length. And we'll learn how to find both of those. Thanks for watching, and we'll see you in the next video.